Hello guys, welcome back to the DSO solutions. Today we will see how we can find maximum sum from all subarray of given array. Let's first understand what all possible subarray can be there in this array. So we will iterate over every possible subarray and we will calculate the sum of each subarray and we will keep track of maximum sum we encountered. If we start with index 0, then -2 is 1 subarray and again -2 1. This is also 1 subarray. Again -2 1 -3. This is also 1 subarray. So like this way, if you start with index 0, these all are possible subarray. If you start with index 1, these all are possible subarray. Like this way, you can see all these subarray. Let's take one pointer, start, that will point to start of the index. So if we want to generate all subarray, so first subarray index start is 0 and ending also 0 index only. So this is one element. Next subarray start index is 0 and end index is 1, two element. Next subarray start index is 0, end index is 2, three element. So like this way, start index is 0 and end index is last index of the array. So if we want to generate all subarray for start index 0, it is taking of n time for only generating subarray. So when first start index is 0 and end index is 0, one element present. So to calculate the sum, it takes one operation. And for next subarray, start index 0 and end index 1, two element is there, it takes two operation. Like this way, so to generate a subarray for when start index is 0, to generate subarray and to calculate the sum, it's taking n square time complexity. And if we do these same things for all starting index, starting index, this we did for 0, then starting index 1, starting index can be 2, starting index can be 3. This way n number of starting index can be possible, right? So again, this n number of element is there. So total time complexity will be O of n cube. If we solve this question with a prefix sum approach, time complexity will be O of n square. So let's understand this. This is the original array and we have to compute the prefix sum array first. The first element of prefix sum will be the same as the first element of our original array. So prefix sum of 0 index will be -2 only. So now calculate prefix sum of 1 index. Take the previous index value from prefix sum, that is prefix sum of 0, that is -2, and take the current index value from the original array, that is 1. So prefix sum of 1 will be -1. Next, calculate prefix sum of index 2. So take the previous value from prefix sum, that is prefix sum of index 1, that is -1, and take the current index value from original array, that is -3. So if we sum this, this is -4. Now calculate prefix sum of 3. Take the previous index value, prefix sum of 2, that is -4, and take the current index value from original array, that is 4. So if we sum, this is 4. This is 0. Now calculate prefix sum of 4. So take the previous index value, prefix sum of 3, that is 0, and take the current index value from original array, that is -1. So total is -1. So prefix sum of index 4 value will be -1. Next, calculate prefix sum of 5. Take the previous index value, prefix sum of 4, that is -1, and take the current index value from original array, that is 2. So if we sum, this is 1. So prefix sum of 5 index will be 1. Now calculate prefix sum of 6. Take the previous index value from prefix sum of 5, that is 1, and take the current index value from original array, that is 1. So total is 2. So prefix sum of 6 will be 2. Now calculate prefix sum of 7. Take the previous index value from prefix sum, that is 2, and take the current index value from original array, that is minus 5. So if we sum, this is minus 3. So prefix sum of 7 is minus 3. Now calculate prefix sum of 8. Take the previous index value from prefix sum, that is minus 3, and take the current index value from original array, that is 4. So if we calculate sum, this is 1. So prefix sum of 8 will be 1. So our prefix sum array will be like this: minus 2, minus 1, minus 4, 0, minus 1, 1, 2, minus 3, 1. Now we have our original array, we have our prefix sum array. Now as an example, if we want to find this array sum where the start is 0 and end is 4. So instead of calculating each and every element value from start to end from original array, we can do like this. We can take the sum value is prefix sum of index 4, because we have already calculated sum from previous all element left side and we have already stored here. So we can simply take the prefix sum of end index value. Let's take another summary example. Let's say start index is 4 and end index is 8. So if we want to calculate this array sum, take the value from a prefix sum of n index, that n index 8, and subtract this from start minus 1 index, because we want to take the value of start index. So take the previous value, take the previous index value. So prefix sum of index 8 minus prefix sum of index 3, that is 1 minus 0. It is totally, if we subtract, this is 1. So here we'll have in number of start point, right? Like start index can be 0, start index can be 1. Like this way we'll have a number of start index. So outer loop will run in time, and for each start index there will be again end index value will get varied, right? From for start index 0, end can be 0, 1, 2, like these ways. Last index can be there. So again for inner loop also it will run in time. So total time complexity will be O of n square. Let's try with this algorithm. If we try with this algorithm, time complexity will be O of n. So this is our original array. Let's take the current maximum is first element value minus 2 and maximum also first element value, that is minus 2. Now go to next element, that is 1. So here for this one element we will be checking this two element value we can take or not. Minus 2 and 1, if we calculate, this is minus 1, and if we only consider 1, this 1 is greater. So we will always take the maximum window, that will be our current window. So we cannot take minus 2 and 1. It is giving less result than only 1. So our current window will be 1. We'll be skipping this minus 2 as of now. This is about window. Now this is in current window. We are having the sum is 1. For one element it is 1. Earlier maximum was minus 2, current max was minus 2, now current max is 1, and maximum also you update now as it is greater than earlier max. Now in next time when we will calculate sum, we will be always considering from 1, not from minus 2. So go to next element value, that is minus 3. So for minus 3 element, we will be checking 1 and minus 3 is greater or minus 3 is greater. So 1 plus minus 3, if we do, it is minus 2, and if we simply consider minus 3, it is more smaller. So greater is this part. So we will be considering our current window is 1 and minus 3. So for this current window, our current maximum is -2 and earlier maximum was 1 and now we will not change as we haven't got any greater value greater than 1. So we'll keep max as it is. Next time when we'll go to next element value, we'll consider from one element only while doing the sum. So go to next element, that is 4. So for 4 element, 1 minus 3 and 4, if we sum this is 2. And if we only consider 4, 2, this is 4 and 2 and 4. If we compare, 4 is greater. So we'll consider our current window only 4. We'll discard 1 minus 3. So for this window, our current max is 4 as earlier max was 1 and now current max is greater. So we'll update our maximum value. Now maximum is now 4. So next time when we'll iterate, we'll consider from 4 element value. When we will do sum, then we will consider from 4 element value. Now next element is -1. So if we do sum 4 and -1, this is 3. And if we consider only -1, this is -1. So 3 and -1, which one is greater? This one is greater, right? 4 and -1. This 2 is greater. So we will consider 4 minus 1 as a current window. So for this current window, current maximum is 3. And earlier maximum was 4. We will not update any maximum as we haven't got greater than 4 any. So for next iteration, whenever we will take any element value, we will consider 4 only when we will do sum. So next element value is 2. So if we calculate 4 plus -1 and 2, so this is so 5 and 2. Which one is greater? 5 is greater. So we'll be taking this window 4 -1 and 2. This window will be taking. So for this current window, our current maximum is 5. Earlier maximum was 4. Now we got greater than 4. Now we will update our maximum value. So maximum value is now 5. So in next iteration also we will consider um, element from we'll consider from 4 element only as our current window start from 4 only. So next element value is 1. So if we see 4 minus 1, 2 and 1, if we calculate sum, it is 6. 6 and 1, which one is greater? 6 is greater, right? So we will take this window. So for this window, our current maximum will be 6. And we will also update our max. Earlier it was 5, now we got 6, so we will update our max. So it is 6. So for next element value, which is -5, so if we sum 4 minus 1, 2, 1 minus 5, this is 1. 1 and -5, which one is greater? 1 is greater. So our current maximum will be 1. And we will take this window only. This maximum window. That is 4 minus 1, 2, 1 minus 5. Now next to the next element value. That is 4. So if we sum 4 minus 1, 2, 1 minus 5 and 4, this is 5. So if we compare 5 and 4, 5 is greater. So current maximum will be 5. As we reached to the last index element, so we'll stop here. So our maximum value is now 6 as of now. So we'll be returning this maximum value. So for coding part, we are taking current maximum value that will keep track of the current maximum Subarray sum, and this max variable that will keep track of the overall maximum Subarray sum found so far. Iterate over each and every element from starting from index 1 to last index. We'll compare with two value. One is for current value and one is for from current maximum what we got meant for current window plus this value current element value, which one will be greater, that we can store in current maximum value. And if current maximum is greater than max, then we will update our max value, and at the end we'll return this maximum value.